Welcome to the deep dive. We're here to cut through the noise, get right to the heart of things, and hopefully give you those insights that make you feel genuinely well-informed. Today, we're diving into something that's, well, it feels potentially groundbreaking in AI. We're looking at a project aiming to fundamentally shift how we interact with computers.
Yeah, our focus is the Multitronic Operating Realm MTOR and its reference implementation, RENTAHAL. And look, this isn't just some quick idea. It's backed by a massive 471-page document described as a technical manifesto and implementation guide. The goal here, for you listening, is to really unpack what's actually been achieved. We want to focus on the concrete details, the hard facts that make this project stand out. So what have they really built?
And it's fascinating right from the get-go, isn't it? Because
Yeah.
a huge part of the story is how it was built. This system was largely, and they're clear about this, AI engineered. So we're not just talking about what it does, but the process itself. How does an AI help build, well, itself, essentially? It really
Yeah.
pushes against traditional ways of thinking about software. Okay, let's get into that core idea then. This shift from command-based to intent-based computing. We're all used to typing exact commands, right? Clicking specific buttons. MTOR flips that. It's about the machine adapting to the human. You express your goal, your intent, and it figures out the steps. It prioritizes what you mean, not just what you type or say precisely. They call it a post-OS event-driven speech-native environment.
So designed for talking to it, basically.
Exactly. And the tech underneath that makes this possible is what they describe as a pure event-driven stateless architecture. Now, stateless is key here. Think about most apps you use. They kind of remember what you did last, right? They hold on to a state.
Yeah, like items in a shopping cart or something.
Right. MTOR doesn't do that for its core processing. Each query, each request you make carries all the information needed for that specific task. It doesn't need to remember the previous interaction to process the current one. And this makes it incredibly agile and really helps it scale up massively. You can have loads of requests happening at once without them getting tangled. Okay, so how does that work in practice? What's the communication layer?
It uses a WebSocket-driven event bus. Think of it as like a super fast internal messaging system. It was built mainly on Python for the back-end logic, the heavy lifting, and JavaScript for the front end, the part you actually see and interact with in your browser.
Right, okay, so let's make that concrete. The source gives this example, asking, who was the first man on the moon? How does that specific query flow through this intent-based system? You say the wake word, computer, then the phrase. What happens next?
Okay, so first, wake word detection obviously fires. Then it's not just hearing words, it's identifying the intent. In this case, it recognizes it's a factual question needing retrieval. That intent gets packaged up into a message, an intent message, which goes onto that WebSocket bus we mentioned.
The internal messaging system.
Exactly. It hits a central server, the universal broker, which is smart enough to know, okay, this kind of question needs this type of worker. It sends the query to the right worker pool, a specific worker node, picks it up, finds the answer, generates the response text.
And then sends it back.
Sends it back through the broker, back over the WebSocket bus to your browser, the client. The UI updates, and crucially, you hear the spoken response.
Which in this case was that detailed answer about Neil Armstrong and the famous quote.
Precisely. Neil Armstrong was the first man to walk on the moon on July 20, 1969, and so on. That whole chain happening almost instantly, that's the intent-based, event-driven system actually working. That's an accomplishment right there.
Okay, so it handles queries like that smoothly, but can we really call it a full AI operating system? That sounds like a huge claim.
It is a big claim, but they explicitly define it as a Python-based real-time AI operating system, or RTAIS. The documentation stresses it's designed to be complete, complex, and seamless. So the ambition, at least, isn't just a collection of tools, but a cohesive, functioning OS layer specifically for AI tasks. That's the goal they've built towards.
And functional means it can handle different kinds of interaction, right? Not just text or voice Q&A.
Absolutely. It's fundamentally multimodal.
Okay, like how?
Well, speech first is a core principle. The computer wake word enables hands-free use. And it's not just basic speech recognition. It integrates OpenAI's Whisper for speech-to-text. And they've apparently optimized it to run, well, even on like an 8 TB GPU, processing faster than you can speak.
That's pretty fast.
Yeah. And for speaking back, it uses the BAR-CAIM model for text-to-speech, with some smart logic to handle longer responses differently.
But beyond voice.
Oh, yeah. It has vision processing. It can analyze camera input, look at images. It does text interaction, so, chat, generating articles, summaries, that kind of thing.
And even image generation.
Yes, image generation too. It can use stable diffusion running on dedicated RTX workers, which suggests it's designed to leverage powerful hardware when needed. So voice, vision, text, image gen is covering the main bases. These are tangible capabilities they've implemented.
Wow, okay. That's quite a suite of functions.
And it's how they're integrated that's also impressive. It's not just standalone features. It pulls in external services, real-time weather data based on where you are, for instance. It even have Gmail integration using secure oath, so you could potentially ask it to read your emails.
Seriously?
Yeah. And for the AI brains, it's flexible. It can talk to big external APIs, Hugging Face, Claude, but also run local models, things like Llama or Llama, if you have them set up.
So it's not locked into one provider.
Not at all.
Yeah.
And critically, it's built with an API-first philosophy using FastAPI. Basically, anything the system can do, you can also trigger programmatically through an API. This makes it super extensible for developers.
And for the end user, the person actually talking to the computer, how does it feel? Is it easy to use?
Well, the interface is browser-based, built with JavaScript, aiming for ease of use. You get that real-time back and forth. You can use voice or type, see your query history.
Standard stuff, but important.
Right. And there are controls for administrators, too. But maybe one of the neatest accomplishments from a usability standpoint is the self-bootstrapping.
What do you mean?
The very first time you run it, MTOR apparently sets everything up automatically. It creates the database it needs, creates the main administrator user, writes the initial configuration file.
Ah, so you don't need to be a database expert or manually configure tons of files just to get started.
Exactly. It aims for a frictionless setup, which is a big deal for complex software. That focus on making it usable out the box is a real practical achievement.
Okay, that leads into scalability. You mentioned it's agile because it's stateless. The documentation claims it was purpose-built to scale to very large, integrated, stateless AI compute realms. That sounds ambitious, aiming for global scale.
Extremely ambitious, yes.
Ah.
But the architecture seems designed with that in mind. It's not just an afterthought.
How so? What are the specific features that enable that kind of scale?
A key one is dynamic worker pools. Instead of managing individual machines, you group them behind semantic aliases, like vision for image tasks or chat for text tasks. This gives you, as they put it, transparent abstraction, zero-friction scaling, and intelligent load balancing. The system routes tasks based on type, not specific machines. If you need more chat power, you just add more workers to the chat pool.
Okay, that makes sense. It decouples the task from the specific hardware doing it.
Precisely. And it extends to decentralization. It supports the idea of people contributing their own compute resources. Maybe you have a powerful gaming PC with an RTX card. You could potentially connect that securely to the MTOR network, maybe using something like NGROK tunnels, and let it contribute processing power that allows for crowdsourcing compute.
That's interesting, like folding at home or SETI at home, but for general AI tasks within this system.
Kind of, yeah. And to manage all these potentially diverse workers, it has real-time worker health monitoring. It constantly checks if workers are running okay. If one becomes unhealthy, it's automatically sidelined, blacklisted. When it recovers, it's automatically let back in. This aims for high reliability across a distributed network.
And what about this realm-based architecture? That sounds even bigger picture.
It is. It's their concept for what they call planet scaling. The idea is you could create entirely separate, dedicated realms within the overall MTOR ecosystem. Maybe one realm optimized purely for lightning-fast text responses, another for complex scientific computation, another for image generation. Each could scale independently, but potentially still communicate across realms. It's a framework for massive, specialized distribution.
Okay, that's the grand vision for scale. What about managing it day to day? What tools do the system operators, the SciFops, actually get?
Quite a bit, actually. They've clearly thought about operational needs. There's frictionless debug logging. It automatically logs details when functions start and end. There are arguments. Any errors makes finding problems much easier.
That's always helpful.
Definitely. Then there's system usage accounting. It tracks metrics automatically, who's running queries, how many, how long they take, even estimated costs, potentially. And this data is updated in real time.
So you can see what's happening, who's using resources right now.
Exactly. SysOps can also send messages directly to users through the system, real-time sysop-to-user communication via WebSockets. Useful for announcements or maybe warnings.
An actual control function.
Oh, yeah. They can manage the AI models, add or remove models from Hugging Face integration, connections to Claude, things like that. They can add or remove those remote RTX workers we talked about.
User management, too.
Yes, banning users if necessary. And crucially, they can even terminate specific queries that might be stuck or causing problems. It's a solid set of tools for managing a potentially large, complex system. These are practical, implemented features.
Right. So moving from the how to the so what. You mentioned efficiency earlier. What are the actual measured gains here? This seems critical to the project's value proposition.
It really is. And the numbers they report are, well, quite dramatic. Compared to what they frame as traditional architectures, MTOR shows significant efficiency improvements. They measured a 73.4% gain in text processing efficiency, 77.2% for image generation, and maybe most strikingly, an 83.3% reduction in energy use when the system is idle.
Wow, 83% less energy when it's just waiting. How?
It goes back to that stateless, event-driven design. It's not constantly maintaining connections or holding on to session data unnecessarily.
Yeah.
When there's no event, it's genuinely doing very little. These gains aren't just theoretical, they're based on their measurements.
And the potential global impact if this kind of architecture were widely adopted.
It's potentially huge. Their projections estimate global adoption could cut computing energy consumption by 405 to 650 terawatt-hours annually.
Which is hard to grasp. How big is that?
It's roughly the total annual electricity generation of France
Yeah.
or Canada.
Okay. That's staggering.
It is.
Right.
Another way they frame it is it's like taking 150 to 240 million cars off the road in terms of carbon emissions impact. Plus, secondary benefits like less need for raw materials because hardware might last longer or be utilized more efficiently. These figures really underscore the accomplishment if the architecture proves robust and scalable.
Now, the story behind how this was built is also pretty unique. You mentioned it was AI engineered.
Yes, that's a central part of the narrative provided by the lead scientist, Jim Ames. He states RENTAHAL was 100% AI engineered and written by a consortium of 6 AIs. Under his supervision, naturally.
6 AIs collaborating.
That's the claim. With Jim Ames acting as, in his words, the test grunt mule for thousands of builds over a year, it's just a really novel development process.
And his motivation, why start this massive project?
According to the material, after a very long career, 45 years in computer science, he felt the need to basically scrap existing approaches, threw everything in the trash, as he put it. He wanted a fresh start, using Python as the core, to tackle fundamental problems he'd seen accumulate over decades. Many, many, many problems, he says. It sounds like deep-seated motivation driving this.
And it's open source.
Yes, released under the GPL 3.0 license. The goal seems to be for it to be a public good, to help foster a more decentralized AI future, not locked down by any single entity.
That commitment to open source is significant in itself.
Absolutely. And when you look at the whole package, the novel architecture, the AI-driven development, the sheer scope, it really does have a feel of PhD-level rigor, as the source material suggests. The complexity and innovation involved are substantial.
So bringing it all together, the ultimate vision seems broader than just efficiency or cool tech. It sounds like there are humanistic goals here, too.
Yes, the documentation mentions goals like educational transformation and universal accessibility. The idea seems to be that by making AI interaction more natural, more intent-based, and by lowering technical barriers to entry, this kind of system could help democratize access to powerful AI for everyone.
Okay. So wrapping this up for you, our listener, what we've seen with MTOR and RENTAHAL is, well, it's more than just an interesting project. It feels like a serious attempt at a revolution in AI orchestration and human-computer interaction. It's an OS, largely built by AI, designed to understand human intent. That's a pretty profound accomplishment if it holds up.
And yeah, it's important to remember it's still very early days for this as a public project described as just a 2-week-old GPL3 release when the source material was written.
Yeah.
But even at this stage, the foundational work, the architecture, the measured efficiencies, they demonstrate, I think, undeniable potential. It challenges you to look past skepticism and actually engage with what they've built.
So maybe the final thought to leave you with is this. We're seeing AI get incredibly complex. But what if the real breakthrough isn't just more complexity, but systems that fundamentally change to adapt to us, to our intentions? Could this be a glimpse of a future where machines don't just get smarter, but actually get better at understanding humans, making all this power genuinely more intuitive, efficient, and accessible for everyone? Something to think about.